Alright, let's hope that everything works fine. It should be fine. We back, baby. What's up? What's up, baby? What's up? Alright, let's get this thing started. Let's see what we got here. Tune! The classic first message. Let's go. Here we go. We're back. To nobody's surprise. Actually, no, to everybody's surprise. How am I? I'm in a mood to yap. To yap about this board. Because I got everything ready for it basically, and it's an ideal time to do it, right? It's a perfect time to do it. It's a weekend day, it's a Saturday, bruv. It's a Saturday evening, yeah? Evening, it's not even evening yet. Afternoon. And I got the right CPU for this board. I got the right mood to yap about it. And I actually got like a pretty decent spark of motivation to actually do it. Finally, right? So we're gonna actually have a look at it. And I'm very curious because like I haven't seen a lot of this board at all. I haven't seen it, like no articles about it or nothing posted really about it. Nothing. So we're actually gonna see how it is. Apparently there's no special BIOS for it. I asked for it and they said that no, there's only the BIOS on the website. Now that's gonna be obviously more restricted than the XOC BIOS, obviously. But it's not, I mean, it could be pointed towards XOC, but realistically, companies see the sales, you know? Most of the sales are gonna be just casuals buying this, you know? They're not gonna be searching for the XOC features and everything like that. Now, for those who are actually searching for the XOC features, this sadly does not satisfy that audience. But it is what it is. Maybe there's an XOC BIOS brewing for this. But it's, of course, if it is, there's gonna be like a very, very limited release. You're gonna have to search for it and everything. So that can get pretty annoying if you actually want to get a hold of such firmware or something like that, you know, and tools and stuff. Because essentially this is a baby Tachyon, right? Essentially it is a Tachyon, but it's a cheaper Tachyon, and it's a normal form factor Tachyon, where Tachyon is like kind of like the 90-degree 24-pin that's way down in the PCI Express slot area, and with the shifted 90-degree socket and the RAMs being like horizontal on the top of the board. Like it's an obscure board. This one is just a normal board with 2 DIMM slots, right? So let's have a look. I've been yapping. Let's have a look. How do I put you here? All right. Yep. There we go. There we go. We have normal lighting this time around. That's pretty cool. So we can actually see. Now nobody's in here because nobody actually expected me to go live. That's hilarious, by the way. Everyone's probably outside enjoying the sunny weather right now. But we're in here and we're enjoying this little piece of hardware in front of us. Now the main thing about this board is actually not stated anywhere in front. That's crazy actually. There's nothing that shows what exactly this board is all about. But we're gonna get to that. We're gonna get to that very soon. Right. So of course it is the Z890 Elite Duo X, right? It's a new board, new release, brand new. Let's have a look around the box, right? So here we have just basically the name of the board on every side. On every side you have the name of the board. That's good. I appreciate that. Let's have a look at the back. Let's see if the back actually shows what this board is all about. So let's have a look. No, ultra turbo mode, DIY friendly design. Yeah, you can do toolless, so like you can do everything toolless almost basically. You have the full picture of the board, which is really nice. I appreciate that. A lot of the brands actually don't do this, but it's really good to put a full picture of the board so you know exactly what you're getting. And you have 5G LAN, I guess they advertised that. Wi-Fi 7, of course. You have a little picture of the back I/O, which is also very nice. I appreciate this. Now these guys are a little bit confusing because you might actually confuse them for audio ports, but they're not audio ports, they're actually buttons. And we're gonna get to that. And I have mixed feelings about this, but I can understand this. And especially for like a bench table, like this is super interesting being on the backside. Now, for a normal user, obviously, like these are going to be very difficult to reach because they're on the backside of the PC, and usually like the backside is right up against the wall or something like that. So you're not going to be able to reach this. But if you're using a bench table, these are actually pretty nice because on a bench table, the main part of the board, which is the back I/O, because you need to access it, is exposed, is very easily reachable. So that's the thing. So these guys are buttons, and you have the normal audio ports right here, all of the USBs and stuff, display out. Then you have some features right here, what's on board. And again, I don't see the point of this board even on the back side. That's interesting. Okay, so let's have a look inside. Let's actually have a look inside. What? Okay, so wait, this board does not come in a anti-static bag. I'm not sure if this is exclusive to the one that I got, but I don't think so because this is a retail one. So this board actually does not come in an anti-static bag.
Sitting very comfortably around the campfire with friends.
Terror, what's up, baby? What's up? Here we back. All right, let's have a look. So we're gonna pull this out. Actually, we're gonna pull the whole thing out. Can I pull the whole thing out? Yes, I can. Okay. So let's have a look at the package. So here's the package thing. Ooh, I actually appreciate Gigabyte giving these grommets right here, by the way. So these grommets are for the M.2, just to support them from the backside, right? Because not all M.2 slots on the board actually have like a backside, like a back heatsink or something like that with the thermal pad. This, I appreciate this actually, like this is really nice because a lot of the heatsinks on top actually bend the M.2, and you get 2 of them even. Is there 3? Oh, you get 3 of them. Oh, that's good. SATA cables. Barely anyone's gonna be using those. You get an Aorus badge. Here's an Aorus badge. Let's see what's in here. Probably the Wi-Fi antenna. Yeah, the Wi-Fi antenna, of course. And then the Easy Connect for the front panel. This is pretty cool for beginner builders who have a difficult time actually reaching and reading whatever is on the front panel here. So, here we go. There's the board. Let's have a look. So, actually, there is a... Oh, that's interesting. They just put... Okay, that's interesting. They just put a... what's it called? The anti-static bag under the board. I guess it was inspected before it was sent to me. Interesting. Okay. There you go. So it does come in an anti-static bag. Let's move this to the side and let's have a look at the freaking board. Let's see. Let me zoom out a little bit. Can I even zoom out? I can't. Actually, I guess we're just gonna do it like this then. Alright, so let's actually have a look. So you get like a little plastic cover right here. I will not be pulling this off. It doesn't really matter. Where do we start? We usually start with the main thing. And the main thing, the main feature of this board is actually the dual DIMMs. And actually, here is where the whole point of this board actually becomes clear. It was made for CQ DIMM, right? For like really high capacity, high clock speed memory. That's why this thing exists mainly, like the main feature, the main selling point of it, right? And CQ DIMM requires 1 DIMM per channel, right? That's the whole point of it. If you have 2 DIMMs per channel, that would probably not work because of signal integrity and other issues that come along with the 2 DIMM per channel configuration, right? So we have 2 DIMM. They're pretty far apart, funnily enough. You can actually see that. They're pretty far apart, which is, in my opinion, actually, that's okay. From a signaling perspective, no, of course, you want to have the channels as close together as possible because of the memory trace length. But from a cooling perspective and compatibility perspective, like this is okay, in my opinion. You can have like thick heat sinks on and you're still gonna get airflow between the sticks. Right next to them we have an M.2 slot, which is toolless. So here you go. And this little grommet right here is, or like this little piece, is actually there to hold this one stable in shipping. You can actually see where it comes into contact. So that's there to keep this one in place so it doesn't jump around. Obviously you would want to, if you mount an SSD on this, you would want to remove this plastic. This is not screwed in or it's not held in by any standoffs. It is actually just glued on with double-sided rubber things, like basically like this. It's basically very wobbly, and there's no other way of removing it than actually, if you want to remove it, you would have to tear this off of the board because it's glued onto the board itself, which in my opinion is kind of like a yikes move. Honestly, I would actually prefer it to be on some form of standoffs with springs or something like that. Now, I can't really show you because there's no real good angle because of the 24 pin, but essentially under here there are like 1 or 2, let me check. There's 2 of them, yeah. There's 2 of them. You can't actually see with the camera, and the angles are very difficult to actually get to. But yeah, that's for compatibility reason. Because some of the SSDs, obviously some of the SSDs have ICs on the backside, and with the SSDs that have that, they would press this down a little bit, right? If it didn't move, then it would be completely incompatible with the SSDs that have the ICs on the backside. So that's why this exists, right? You have postcode right here. You have an easy release mechanism for the PCI Express slot. Let's have a look at this guy right here. So this guy, same thing. You have the movable heatsink on the backside, and I believe, let's see. So okay, so there is no heatsinks on these 3 M.2 slots. So that's in total of 5 M.2 slots. I'm not exactly sure. So this one is South Bridge. You can actually see that, by the way. You can see this. So you can see SB. So that means South Bridge. So this one is connected to the South Bridge and it's Gen 5, I would assume. I'm not exactly sure. Usually these metal guys are Gen 5. M.2, it only literally says M.2 on it. So I'm not sure if this one is actually Gen 5. But, there's like a little graph. PCIe G4, Gen 4. So no, it is not Gen 5. It is Gen 4 4X. And then this one, you can see PCI Express Gen 5 right here, Gen 5. This one is CPU. I can't really find where the name of this M.2 actually is. Usually the name is right next to it, like here. I would assume actually the name is under this. Oh yeah, it is. The name is under this heatsink right here. The CPU says right here, right under it. Okay, So we actually get information what the slots actually are. So this one is CPU as well. You can see it right here, CPU. South bridge, and then you have the configuration right here. So PCI Express Gen 4 4X, and then you have even SATA support on this one, which is pretty cool in my opinion. So like some of the M.2s, especially if you're benching, if you're hardcore benching, some SATA M.2s are actually much easier to run than PCI Express Gen. So yeah, you get 2 M.2s connected directly to the CPU, and one of them is Gen 5, and the other 3 are South Bridge. Here, I'm actually not, so here's the one that is populated. We saw this on another board that didn't have this populated, and I'm not exactly sure what exactly this thing is. I was assuming that this was actually the clock gen. I'm not exactly sure. I could actually, like, I can bring you in and you can actually see the name of it. And you can search up what exactly this CKA. I would assume that, I don't know. I would actually assume that that's the clock gen. But yeah, you have elite writing right here in big font, big special font. Right. What else can we look at? Let's see the number of this board. The SN is 967. Oh, interesting. Keeping up with the memes, I see. Keeping up with the memes. These slots right here, I would assume that these guys are actually 4x physical. That would be cool if they were 4x physical. Now, let's have a little sneak peek at the VRM. So here's the VRM. And the heatsink. Let me see if there's a heat pipe actually in this thing. It doesn't look like there is a heat pipe in this. It's just very chunky heatsink. You can actually see, yeah. Very chunky heatsink right here. Jesus Christ, okay. We can actually take this apart. I'm actually curious about the VRM on this. Next up, we can actually count the fan connectors. So one fan connector is right here. That's 1, 2, 3, 4, 5, 6. 6 fan connectors. That's not that much. It's enough. But yeah, that's not that much actually. Usually Gigabyte put like 3 fan connectors right here at the bottom. But in this case, they only put 2. There's no fan connector right here. Sometimes they actually put fan connectors right here for AIO and pump. Next up, we can look at around the side. So you have the postcode, of course. You have the postcode right here. You have the post LEDs right next to it, basically, right? Which are useful as well. You have the 24 pin. The 24 pin is actually fold over pins. It's not solid pins, which is interesting. Let me see if the 8 pins are. Yeah, the 8 pins are solid pins. Interesting. So then you have the fan connector type C 3.0, which is the only 3.0 front panel. 4 SATA ports. Front panel connectors. Let me see if this is the RST switch. This guy right here. So this was clearly the CMOS because it's right here. This guy doesn't really... there is, yeah. RST right next to it. Okay, so we have an RST switch right here. Here's a little description of the pins, what exactly they are. And you even have a plus. So you know which one is the plus side. This is a really cool thing that Gigabyte has been doing for decades now. For literal decades. And they keep doing it. Here's the single BIOS. So there is no dual BIOS on this. There's only single BIOS. Obviously the 2 fan connectors right here. This is the Thunderbolt connectors right here. Dual internal, or you could say front panel even. USB 2.0. You have the SPI TPM, which can be used for many things. You have the normal RGB, addressable RGB, and that makes a total of 3 addressable RGB connectors on this board. LED demo, which Gigabyte actually use for their display. So when they're displaying the board, they connect this and all the RGBs are actually powered. Then you have the audio right here. The audio chip is ALC1220, I would assume. I can read that correctly. This is the I/O chip. And this is the LAN chip right here, Realtek 5G. Right, the PCI Express slot is the, how's it called? Robust PCI Express slot. I actually like these. Let me see the mechanism. How does the mechanism work? If this locks in, you just release it like this. Perfect. Then you have a little plastic piece over the VRM. This is only plastic and it actually bends quite a lot. Gigabyte has been doing this on their boards recently, and I'm not too big of a fan because this is very cheap plastic. So I wish they changed the design a little bit from this, make it a little bit more robust or at least better looking. We have a back panel. So just like on the pictures, you have a back panel right here, and here's the switches that I was talking about. You basically have all the switches on the back, so there's no internal power reset CMOS Q flash switches. It's all on the back. And honestly, the configuration that they used here is actually pretty okay in my opinion, because two of the switches actually come out. You can see that the buttons are slightly sticking out, and two of them are not sticking out. You can rub your finger over them and you will not be able to press them. And I would say that the right ones are actually the ones that you can't press. So the reset, obviously you don't want to press reset while the PC is on. And then the clear CMOS, obviously you don't want to accidentally press CMOS. However, power and Q flash, realistically, it's not that big of a deal if you accidentally press it or something like that. But let me see. Yeah. Okay, reset. You can't even press it with your finger or nail. It's so deep. Yeah, you can't actually press it. Okay. How many USB ports? So these guys are 2.0. These guys are 3.2 apparently. And you have the BIOS USB port right here, so you can flash the BIOS with that one. You have a USB 4 display port even, so you can use this as a display port. You have display port right here, full size, and more USBs, 5G, Wi-Fi 7, digital, or actually no, optical, sorry, and then analog in and out. Let's have a look at the back side. Let's see the backside of this beauty. Oh my goodness. Actually full-size backplate without any design on it. Which is crazy, by the way. Usually, like, I'm actually pretty shocked because I never looked at the backside of this board. So seeing like a completely empty backplate is actually crazy. Also, guys, I need to ask you, is the stream okay? Is it lagging? Is it buffering? Is it all okay? Looking great, good. So, you have an indent right here. This is for the backside thermal pads, so that make contact with the board. The rest doesn't look like there's any contact. It's only screwed. There's a little bit of yeah, it's a little bit loose, funnily enough. Not by much, but it's a little bit. The backside, you can't see the traces. They're covered. Right? You can't see the traces. You can see the backside of the VRM. There you go. All right. Now, we can actually look if this board is bent around the VRM area. Actually, no, it's completely flat. That is perfect. So the heatsink is actually not bending the board or anything like that. But yeah, we can actually look into disassembling it partially. I would actually like to partially disassemble this thing because I want to see what's underneath. So let's have a look what is underneath. And even, okay, so we have an 8-layer board actually. I can show you that. So it's an 8-layer board. Ooh, very short screws, very loose as well. I'm not sure about, like, you can see, like, so it's very loose. I'm not sure about that. That should be tightened up, and they should be using the blue grease that stops the screw from turning when it's installed. As you can see, there is no blue grease on the thread. So Gigabyte, you should really fix this. If you're watching, if anyone's watching, you should really put some blue grease on top of this so the screw does not turn well when the board is being shipped, because when the board goes through vibrations and stuff, the screws will slightly loosen up, and they're extremely short and they actually might just fall off depending on how hard the shipping is. So there you go. That's one suggestion, the first suggestion for this board. All right, let's have a look.
Loctite.
You mean the Loctite? Yes, exactly. Thank you, Terror. The Loctite. So let's pull this off. And we need to place it on top of this thing again. Loctite. See, I'm so glad I have you guys. You guys are so smart. There we go. So we have quite a bit of support on this backplate, which I absolutely love, by the way. This backplate also is very friendly for just placing the board on top of a table like this and benching it. So it protects the board. The board will not bend because it has so much support on the backside. Like, this is really good, Gigabyte. I love this. All right, so let's move this to the side. And let's have a look at the back side of the board. Let me see. Ooh, what is this? Where did this come off from? Is it? Where did I didn't even notice this, by the way. I just moved the board and this thing fell off. It actually looks like it tore a bunch of PCB off. Where did this come from? Is it actually this? It is. It's literally this. Oh my goodness, Gigabyte. Oh no. Oh no. Okay, so this is basically it's a standoff that is soldered onto the board, onto the top layer of the PCB, which is copper. Obviously, you can see copper right here. Why? It's not that simple, because it literally pulled the mask of the freaking top layer off. There's no soldering involved anymore. There's no top layer anymore. So no, you can't solder it back on. It literally pulled the solder off of it. Super glue would work, yeah, super glue would work. But okay, so Gigabyte, we have to fix this. Okay. So that also means, yeah, I would be able to fix this with super, obviously. It will not be an ideal fix. But yeah, this is basically it. Oh no. Okay. Well, it is what it is. We'll remember that. Hopefully. So I can actually screw on the back plate again. But there's more standoffs like this. So the next standoff is right here, as you can see. The other standoff is right here. And there's more. There's one around the controller area, actually, right here. So right here is a standoff. Here, here, and here. This one is actually just a screwed in standoff, so this one will not break off. This one is screwed in into the plastic piece, into this plastic cover right here. So let's unscrew it. Is this the one? This should be the one. Yep. There we go. So first the plastic piece needs to come off, which has these screws right here. Oh, these guys are tight. And I'm grabbing the backside of the board here so I can provide support when I'm pressing on it. There you go. Because these guys are actually fairly tight, believe it or not. So this guy actually comes off very easily. And is it not loose? It is loose. So, okay, so this is actually, it has a see-through right here, so that would light up this logo right here. And you can actually see the LEDs. You can actually see the LEDs. There's 3 of them. 1, 2, 3. There's your LEDs. That's going to be shining through. And now we can actually see the full heatsink. Oh my goodness. There's actually a slight, is it called convex, right? Convex design to these, interestingly enough. So we can actually unscrew. Oh, you can actually see the switches right here. They're very tall, funnily enough. They're very tall and very slim. So if you actually if you press this with a lot of force, you might actually just bend or break off the thing. And they're like, these guys are actually known to break quite easily. So you have to be a little bit careful with these guys. But yeah, let's unscrew the heatsink. Is this a screw? Yeah, it is. Okay. This is a Wi-Fi. These guys are the VRM heatsink screws. There we go. And now I need to swap so I can unscrew this guy and be very careful because there's resistors around it. For the VRM controller, there's the VRM controller right here, and this is probably the I2C. I2C, I wouldn't, not really I2C, but this is the voltage monitoring for the socket voltage. Or I guess you could also take this as a on-die input voltage, so VCCN for the CPU. This would be the on-die monitoring chip. Usually they put it right here. All right, let's pull this off. Wait, is this a separate heatsink, by the way? Yeah, it is. Okay, so no heat pipe, right? No heat pipe. It's very heavy, actually. Like, even this piece is actually very heavy. And then the second one. There we go. Easy remove. The thermal pads actually didn't break while doing this, which is really cool. I like those. Usually Gigabyte uses different thermal pads on like more the premium boards. It's a very distinct thermal pad to Gigabyte. It has like these metal shiny specs inside of it. They've been using it for quite a while now. But this one, no, just uses a normal thermal pad. I approve of this, actually. Makes it much cleaner to do this, to remove. So here we go, finally. The massive VRM of this board, which is actually pretty impressive. I will try to use the light for this, which will make everything a little bit more yellow, sadly. But it is what it is. That's just my setup, the limits of my setup. So here you go. The power stages, NCP 302155. I would assume the 55 actually stands for 55 amp. Now that's, again, I'm completely assuming this. But yeah, that's what I assume. Let's see the controller. If we can get a good angle for the controller. NCP 81537. Here we go. That's our controller. Here we have, this is actually the DC to DC dropout converter. I think it's called dropout converter for voltage control for the fan, for this one right here. So if the fan is using PWM, it's using 12 volts. If it's using DC, so voltage control, you need a DC to DC converter to control that. So that's that. Here's the rest of the VRM and the bottom two power stages. Let's have a look. NCP81525C, if I see that correctly. Maybe that's a 6 at the end. Not exactly sure. It is a 6, actually. 81526C. There we go. Beautiful. There's an empty space for an IC right here. And it goes into... that's basically LAN, I think. So this one right here, these empty points right here, I would actually assume that that's LAN. Let me check the backside. Yep, it is. It is actually LAN. You can see it right here. It's empty spots for a LAN. And right next to it, it's populated, which is the 5G. Okay, so that's our VRM here. Nothing else interesting around the VRM area. It's just a VRM. No like special chips right here or anything like that. Nothing going on. Yeah, that's the full board basically. Now there's one more thing. And it's the socket area. That's what we would want to see. I want to see the socket area. Let's have a look. Let's have a sneak peek at the socket area. There we go. So these sockets actually come with with spacers pre-applied. You can see this white thing, right? This is basically like a little spacer for the loading mechanism, so it doesn't bend the CPU as much as it would without it, right? So this comes off. Oh yes. So now we have almost the naked board, right? We only have these guys, which we need to tear off if we want to remove them, and the PCH, which we don't really need to remove. There's nothing really interesting going around it. Also, one little interesting thing, this is actually a pretty decent spot for the battery. It's very easily accessible. It's right next to the CMOS. So I approve of this actually. Like, this is really nice to have right here. But let's have a look at the socket, right? You can't see any traces. It's all under a ground plane. Or actually, is it even under a ground plane? It's just under the top layer of the PCB. Doesn't even look like there's a ground plane going over it. There we go. Nothing else special going around the socket. Let's have a look at the back side, at the filtering. Is there any drilling going on for the memory traces? It does not actually look like there's any drilling or via drilling going on the memory traces. Interesting. That's all the PCI Express lanes right here. And that's the memory. It's all covered. Now this in the backside, there is a ground plane covering the backside. No capacitors really. Not on, or actually no, on top there's a couple capacitors on the top, but nothing really going on the traces except for this little one capacitor right here. And that's it. That's it. That's for the VDD2. Cool. Not solid pen? Yeah, it's a folded, which is interesting, yeah. So 40 minutes to do like a full analysis. I can actually also mention there's a bit of input filtering right here with the
exclamation mark no VRM cooling.
yes. there's a bunch of input filtering right here and a bunch of output filtering as well. No polymer caps or anything like that, just normal through hole. That's just a cost cutting measure, which is fine for a board like this. But beefy VRM. Let's put this back on. So, because we need it. We need it. All right. So, there's a little watermark right here. Or I shouldn't say watermark, liquid mark going on around here. So I would assume that that's from the motherboard cleaning process. Can you go into the hole? There you go. Let's tighten these guys up. Now, I can actually just straight up put the CPU inside. So we're gonna be using a 270K plus. This one is actually delidded and relidded with liquid metal. So the temperatures are actually going to be really good on this one. Pre-binned CPU. By yours truly. There we go. So, mounting mechanism. So this is how I do a mounting mechanism on this, because we're using a custom block on it. I use these little grommets because I don't have the native mounting mechanism for the block. It doesn't work on this socket. The block is too old. And even the one that works on this socket, I dislike it a lot actually. I don't like that mounting mechanism. Actually, in fact, I don't really have to do this. I can only just do this and then just put the low spacers on. So these guys just go straight on. Chink. Yep, just like that. Yeah, I can just do this. There we go. I have to use these guys. Okay, let me clean this. Right, that's acetone, cleaning it with acetone. You do not want to have acetone around plastic parts. It's gonna eat through them, quite literally. Also, one little thing that I noticed just now is it has both sides for releasing the DIMMs. I actually love this. Love that. All right, so here's the bench, right? The classic. Right, let's put this on. So we can now put this on without the mounting mechanism falling off. So that's why I do that. There we go. Now I can literally just mount this. So we're gonna be using a cryo sheet. It's actually stuck on this block because it was actually previously used with this CPU with the configuration, but not with this board though. So I can just literally mount this on top. Hopefully the cryo sheet actually doesn't fall off. It should still stick, yeah. There we go. Oh, that's the wrong way. Jawohl. Ah, there it goes. There it goes. Classic cryo sheet. So this is the right orientation for the block. My bad, my bad. It is quite annoying actually to mount it because it has so much play room, but once it's on, and it's incredible in terms of performance. This should be okay, and then you can literally just do this.
You can squeeze it all the way down because it's gonna hit the spacers, and the spacers will stop it from screwing in any further. There you go. Yes. Yes. Oh, that one's tight actually. There we go. There we go. Yes, that is our block. So now the connectors, and yes, I will actually run this board without a heatsink. I'm actually curious how hot this VRM gets without a heatsink. No worries, by the way, it's not gonna burn. I'm just curious. All right, let's grab some RAM. What are we gonna be using for RAM? Well, of course, we're gonna be using the Manta V-Color H24M. One of the best RAM for this platform, funnily enough, for high-speed overclocking. And the GPU, of course, it's gonna be a 5090D Hall of Fame. So let's plug this boy in. Oh, that is a very interesting sound to the slot. Usually it's more kind of like a click. This one was not a click. There you go. There you go. Did I connect this already? No, not yet. Where is it? Here it is. We need power, of course. We need power for this boy. There we go. Of course, we need the cooling. Cooling is actually gonna go over here. Ooh, funnily enough, I'm gonna plug this in into the RST switch because I'm gonna be using these guys for power on and reset. And I actually forgot which one is power on and reset. I believe it's these two. I think this is power on. I'm gonna have to check the backplate. Funnily enough. Here we go. Where you at? There you go. Now we need the 12 pins. The two 12 pins. There we go. Alright. Back. Alright, we have CPU cooling. Isn't that clever? I'm gonna move these guys. There we go. And all of the heat sinks off of my table. Because I need space. I need some space around here. Alright, here we go. Bank. Do we see any RGB? What? It turns on immediately. Okay, so the postcode actually works flawlessly. That's very clear. Postcode works. We're gonna have to put a postcode camera on this. Do you agree? Do you agree on the postcode camera? Yes, I have it hidden somewhere in here. Hold up. Comes with the cable. It is what it is. Can I put you back? There you go. It comes with a cable. Also, this RGB is insanely bright. There's four. There's four of them. What the? You can see this.
Classic Gigabang.
Gigabang. Actually true, it's Gigabang. Actually the post LEDs are not that bright, which is cool, by the way. The post LEDs, do you know the little LEDs that indicate the posting behavior? They are usually insanely bright, and they're so bright that you can't read what is right next to the LED. And these guys are, you can
Yeah, there's basically there's just a light. There's just a light, nothing special. You can clearly see what is right next to it. So good improvement, Gigabyte. I love this. Okay, not bad. We're min-maxing. Love that. All right. I need to turn those LEDs off. I swear to God, what is this? What is the comparison versus my flash? So that's my flash, by the way. Phone, right? That's phone. That's the LEDs. It is literally... Yeah, it is about as bright as the freaking flash on the phone. That's crazy, bro. The torch, right? It's called the torch.
Reminds me of OCFRGB's Lamal.
That's crazy, bro. So, what do we have here? What do we have in the back? Okay, so we have the BIOS in the back. And I'm gonna have to move you around. Yeah, it's a bit of a scuffed setup. I don't have like 15 cameras in different angles, so I could easily switch between them. I just have this one camera. Jawohl. Alright, let's have a look. I need to close the sheets as well, because the sun is coming in. The sun. Oh, I forgot about the M.2. Yeah, I need to grab the M.2, of course. Oh my sweet goodness, this LEDs. How do I turn them off?
Two?
Oh, wait. Where did I put my... Oh, there it is. Yes, here's the SSD. There we go. Now we can actually boot it up straight up. I don't even know what to test on this, to be honest. I guess the overclocking. I guess we're testing the overclocking. I haven't read the chat at all. But let's have a look what is on our screen. Boost is activated. Okay. This feature allows you to increase performance. Will enable XM. Do you want to keep it on? Well, I appreciate Gigabyte giving the message. I would assume that a lot of people entering the BIOS immediately will select yes because it says performance. But it might actually end up being very unstable depending on what kind of CPU, RAM, what kind of configuration you have. So ideally you set no. Anytime, learn more. And you get a QR code. Appreciate it, Gigabyte. Appreciate it. Got it? Okay, so it resets. Where's Cam 2? Cam 2. Alright, here we go. Cam 2. It's a little bit close to the... Where is the second? Ah, there it is. It's a little bit blurry. I know. We're working on it. Watch this. Configure. So. Beautiful. Oh! That is beautiful! I love it. There we go. Postcode, baby. Why is it resetting? It's resetting 3 times now. What BIOS are we on? I need to actually check. Do we even have a website? Z890 Elite Duo X. Let me download the latest BIOS. What is the latest BIOS even? BIOS. It's a beta BIOS. HUDIM. Apparently they put HUDIM support. Keep it on. No, got it. Why? Why is it? Can I enter the BIOS?
No.
Am I doing something wrong? Do I need to spam delete?
Now.
We went through 5 restarts before we came into the BIOS. F1! Oh, F1 is actually microcode 121 already. What is the first release BIOS? First release, and then the second one introduces ultra turbo mode for Intel level 1, level 2, level 3. Extreme mode, maximum performance. Okay, so the second one seems to be quite a bit of an update. It's actually smaller. It's smaller than F1.
What's up, madness?
What's up? Should we? Should we just do it? Or should we just do a F1? Let's have a little overview of F1. Right? F1 sometimes is actually crazy. I've had experience where F1 was actually... You couldn't get it on the website. And it was insane. It had some special things unlocked and everything. And then they locked it in the upcoming versions. In the later versions. So let's see. No SP readout on this. No biscuits. Right, as we can see. Right behind the chat, you can see the ultra turbo mode. And this is what it... There's already these options in the BIOS. Oh, that's interesting. Okay, I wonder what they did, because they specifically stated that they introduce ultra turbo mode. I guess for the refresh, I would assume. Or something. No, but this is refresh though. Okay, I'm a little bit confused because the options are already there on F1. I guess this is the unlocked. Yeah, cracked. No, that would be hilarious if this is unlocked cracked.
Is this the source BIOS version?
Sauce? Well, it's on the website. So if we flash it to F2 or F3, you can still flash F1 because it's on the website. Let's have a look though. No bootable device found. The rest of the menu is basically standard to Gigabyte. Q flash. Let's see how the no disk drive found. Load default. Let's just go straight to advanced. Okay, so here are the arrow leg options, which are plentiful. The default option apparently is default settings performance, not baseline. Ultra turbo mode disabled because we didn't apply it. Recommend me profile. I never tested this. What it is, I don't even want to know, honestly. So I don't know exactly what this does. So we have Intel Turbo or 200S boost, which I'm not too big of a fan of actually. CPU upgrade. I would assume actually CPU upgrade becomes available when you do something. I don't know. BCLK output source. Yeah, you have eCLK. You have eCLK. So you could go all external SoC, all internal SoC, external, internal CPU, all internal mode. Usually you would want to go all external, obviously, if you are doing eCLK. You have CPU performance ratio or clock ratio. Efficiency, so that's performance cores, E-cores, ring, NGU, D2D, iGPU. Then we have advanced settings. Over temperature protection, which starts at 105. So if you want to lower the temperature threshold, you would want to do this option, TCC activation offset, which is basically like a negative offset to the 105C limit. So if you're doing like 5 here, that means your temperature limit is 100. If you're doing 10, it's 95 and so on, right? So if you want a lower temperature limit, you would want to use this. Awesome. Speed shift, thermal monitor. This is all the turbo options and power saving options. Thermal velocity boost, you can see auto, but it's enabled. CEP, manual, you can see 3 options appear. These guys are enabled by default. They're if you want to disable them, they're useful for then overclocking the CPU, so you don't throttle the effective core clock speed once it's under load. Legacy game compatibility, that's actually a really old feature from 12th gen. Under voltage protection, you can also disable this for CPU overclocking. We have AVX settings, and then you can set the offset to AVX. You can set it to 0, for example. Active turbo ratios. You can limit this, by the way. You can lower them, and the CPU will apply the ratios accordingly to what you set. C state, turbo power limit per core, granule ratio. High bandwidth, low latency are actually features from Gigabyte. If you enable them, it will tighten up the memory a little bit and increase the TREFI. It's a little bit all over the place, but it's arguably one of the better ones compared to rivals, compared to MSI, ASRock, and Asus. I would rate it quite high, in fact. It's pretty okay. Then you have DDR5 XMP booster. You can use this for like a little quick overclock, and it actually applies some of the settings in the background as well for the memory. So it might actually make some frequencies work where they wouldn't if you just set them manually, right? It just sets some stuff in the background. Let's just keep it at that. Gear mode, memory boot mode, real-time memory timing. I actually like to disable this. Fine granularity refresh. This is enabled, of course. Memory enhancement setting. There's CKD enhancements now. Channel timing, just your standard channel timing. And really nothing else in this menu, sadly. Which is a big shame. You get this, which is fine, in my opinion. But you would want a little bit more with this board. If you really wanted to push. Core voltage mode, single core, adaptive, override fixed. Keep in mind, this is the input voltage for the CPU, not the LVR voltage. I would assume. Or is this the DLVR voltage? So the input voltage, because it says DLVR in, so that would be the input voltage. Yeah, I can't actually confirm that. Oh yeah, you're behind the freaking postcode. I guess I could make it smaller, yeah, like this. There we go. Internal VCCSA. Internal memory, that's actually not the VCCSA that we're looking for. The VCCSA that we're looking for, is it actually? Wait, I thought there were 2 options. Aha, it's just this and then memory, right? It's VCCSA and then memory. Yeah, so it is, yeah. System agent voltage controls that, because there's 2 VCCSA voltages. One's the input and then one's the internal one. NGU offset. Keep in mind these values on the right side, they're only there for, I don't know what they're there for, honestly. Like, it just shows a value, but it's not the actual value that it runs at. So voltage settings. We have load line, It's classic. VDDQ, IO, CLK, VDD2. And we have the RAM voltage. We can actually check what kind of max voltages we can apply to this. So let's see. What kind of voltage can I apply to this? 1.5 is the max VCCSA. That's fine. Honestly, for daily limit, in terms of like what you would limit the normal users to, it's fine. That's correct. You would not want to exceed that, but... Oh, there's system agent voltage. Never mind. Here it is. There you go. So that is actually internal VCCSA. I just skipped over system agent. So this is the system agent voltage, right? So there we go. 1.6. That's actually good. 1.6 is fine. It's not... Actually, no, it's fine even for XOC. And for valid. For G4 valid. That's fine. 1.6 is fine. IO voltage limit, let's see. 1.55. That's fine as well. Completely fine. VNNA on. 1.1. It could be a little bit higher. But 1.1 is, in my opinion, again, fine. 1.1 is where a lot of the CPUs just kind of fall over in terms of scaling for D2D. Because this voltage is responsible for D2D. That's where they start falling over. NGU voltage. That is a lot of voltage. Usually you kind of want to max out at 1.1. Not any higher. You don't really need any higher, to be honest. That's our limits for the main voltages, for the overclocking, memory overclocking, and oh, I guess you have VDDQ as well. Let's see. 1.8, that's amazing. 1.8 again. 1.8 again. VDD2, 1.6, that's fine as well. Even for Gear 4 maxing out. So the voltage limits are crazy. 1.8, that's a classic Gigabyte. 1.8 is also fine. It's right on the limit of being fine, actually. Except for really tight memory overclocking. So let's say you're trying to push really tight timings at high frequency. Then it's not fine anymore. But that's XOC level. Otherwise, 1.8 is fine. That's it for the main menu. So let's see settings. Platform, that's classic. Display output, internal graphics, we can disable that. You have the PCI Express link menu. Good. Oh, you have the RST switch. You can program this switch to do these things, and I program it to do safe mode, which is kind of like turtle mode on these boards. That's fine. That's completely fine. What kind of voltages do we have here? Ooh. VNNA on, VCCSA. Okay. That's it for the settings menu. Here you have the information about the board, CPU and everything. Secure boot. Advanced mode. No option for RG. Am I blind? I hope this turns it off, because the LEDs are insanely bright. Alright, save. Base. Hopefully I reset all the voltages. Are RTTs still stuck? No. Now they actually use the correct RTTs. Watch this. Watch this, baby. Watch out, baby. Watch out. There you go. Yeah, they use correct RTTs now. I mean, before it was very easy. 20 was 0. GIF! What's up, baby? What's up? That's what's up. We've been talking about you a little bit in the Discord, you know? But yeah, before they were using 20 as 0, so off. And then 40 was 34, 60 was 40, 80 was 48, so on. It was confusing. To me, it was not actually, because I used gigabytes so much that I just kind of got used to it. But yeah. Go! Go, 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 go. I did reset everything there. Yeah, okay. Okay, now I have to check which one is power. Power is the bottom one. It works! Okay, let's plug in the SSD. No! I accidentally pressed the switch when I was trying to put in the SSD. That's 11. Actually, now that I think about it, that's actually pretty annoying. You might accidentally press the switch. Alright. Oh, I need to remove the plastic if I want to mount this thing. Right. Oh, let's remove the plastic then. I'm gonna put this back into the box because it's useful. It has the little grommet on top of it. There we go. Okay, bink. Oh. Alright. Let's get in. I can make this bigger again. Actually, this one was here, wasn't it? Yeah. That's better. That's better. .7 what? VDD on the memory? If you have it cooled enough. Potentially, yes. A lot of the boards actually don't like that high. So. Flash figured out. On what? On Gigabyte or on MSI? On MSI, I'm aware. Actually, I was testing it with him. I think VNN on was still the same, but the VDD2 voltage is what he unlocked, if I'm not mistaken. Not VNN on. With the testing, Hermit Cave, okay. Hope you're doing well. Hope you return soon. We await your arrival. Have a good one. Keep. So now you can actually see. Alright, let's have a little first look at the power. What kind of power limits do we have here? And do we have voltage readouts as well? I'm actually curious. Do we have voltage read? Okay, so Gigabyte is using D2D 3 gigahertz, so 30 multiplier, and NGU 32, which I'm not a fan of. Like, it should be max 30, basically, 30 multiplier, not 32. That's kind of like coming to the limit of a lot of CPUs. It actually exceeding the limit of a lot of CPUs. So, not a big fan of this. Let's see the volts. So we have this, of course, DLVR in, which is our V core voltage. There we go. VNNA on, That's another V-core voltage. Actually, in fact, this is the V-core voltage, literally on the VRM, and that's it. No other voltages apparently, which I'm disappointed by. Let's see the power limits. So the power limits are 250 standard. Nothing special. Let's have a look. Let's have a look. How good is this? Okay, so 250 completely maxed out. 5.55 gigahertz. 4.6 on the E-core. Temperatures are absolutely insane because it's a Delidded CPU. Classic Gigabyte as well, by the way. Like, Gigabyte somehow has really good CPU temperatures. And it actually beat the previous score with the same profile. Interesting. Okay. Okay, I see you, I see you. Should we jump straight into overclocking? I will limit NGU and D to D to 30. So I'll just apply those. Okay, let's jump in. What kind of preset profiles do we have? Hynix 24G. We have quite a lot, in fact. We have quite a lot. Let's try out an XMP. So XMP for this kit is 8200. What happens? We'll look at the voltages, look at the VDDQ and CLK, IO voltage, VDD2, but I think there was no VDD2 readout. And then system agent voltage. And if system agent voltage is lower than 1.35, we have an issue. We have an issue. It's 1.3. It's 1.3, okay. VNNA on is actually 0.8, which is funnily enough higher than the default. The default is 0.77. That's hilarious. Okay. I'm not too big of a fan of that SA voltage, so that's why I will limit this to 30. Because I don't want any trouble with the NGU. When you're pushing DDR5 clock speed on this platform, and you have a 30x plus multiplier on the NGU, you put an enormous amount of stress on the SoC. And some of the CPUs cannot run stable at those settings. So you need SA voltage for that. And some CPUs, just it doesn't matter how much voltage you apply, they will not run, right? That's why. So let's have a look what they do in terms of timings. Okay, so Gigabyte actually configures some of the timings. Actually, one of the timings, it seems like. They configure TREFI, which, again, I'm not too big of a fan of. It's at least around the 32,000 mark, which is still okay, but it's not good for really high temperature situations, right? TREFI is very sensitive to temperature, makes the memory very sensitive to high temperature, and it might actually error out. And it seems like that's really the only timing that they changed. Everything else is stock. Very slow, of course. So let's have a look at the volts. That is across the board completely fine. Sadly, we don't have VDD2, which I'm so sad we don't have VDD2. I would actually assume that VDD2 is somewhere in the range of 1.35 to 1.4, because VDD2 sometimes actually syncs to the VDDQ voltage or VDD voltage of the memory. So it could be 1.4, which is fine for this actually. For this board it's fine. And it seems to be running just fine. Let's have a look at a little stress test, a little quick stress test. Making me feel weird. Well, there's actually like a very specific calculation that goes into the value that you're looking at. So it is an actual value, which is pretty cool. But yeah, it's not 32767, you know? It's not that. I need a fan on top of the RAM. Of course. Ooh, do we have a fan connector right here accessible? Yes, we do. Do we have a MOS temperature, by the way, sensor? Let's see. MOS temp? Yeah, VRM MOS right here. There it is. This one is not working, obviously. This one is... Actually, no, it doesn't look like it is. It's 44. It's been 44 for this whole time. Is it actually? Okay, so it's definitely not measuring the MOS temperature. Oh no. Which one is the MOS temperature? Do we have this? No, this is not also not the... My god, really? Oh, that's a shame. That is a big shame. Let me do something. So, reset and then layout, restore. Okay. So, we don't, obviously we don't need this. We don't need these. We don't need this, of course. That's it. Wow, there's really no more sensors. Oh, that's a shame, man. That is a shame. Oof. It actually reset everything. Wrong one. There we go. Okay, let's get back in. And so that's our XMP profile. Now I'm actually curious for 88. 88 should work straight off the bat, literally. Set should work. Oh my sweet goodness, I cannot believe what I'm seeing on my screen. In Discord messages. I could not believe what I was just seeing. So 88, those timings are actually completely fine in my opinion. The voltage is also fine. So let's just find out what happens. I'm actually very curious what happens. This CPU is very capable, by the way. It can almost run 92 with minimal work. So 9200 on the DDR5. Let's see. Okay, yeah. It is definitely just a apply and run type of situation. So again, we have TRFI higher than before, higher frequency. Everything else is stock. Ooh. They even apply the TRFC and PB, which is actually fairly tight for this, by the way. For 88, this is about as tight as it gets, by the way, for reliability. Oh, it's gear 4. Oh no. Can we set this to gear 2? You are actually correct. A few years ago, well, I was doing 92 over 2 years ago. So yeah. Oh, that's funny. For the general people. I get it. I get it for general people. All right, let's see. Gear 2, 8800. Limit 131. I doubt the limit is 131. The limit is 262 something. I forget what the max value is actually. 262, yeah. Gigabyte lock TREFI. Okay, let's have a look. Oh wow, that doesn't work. TREFI. Boop. Okay. Now check ASRock. I was just on ASRock. It is 262. Unless we're talking like maybe lesser boards, let's say the ITX ones that are not meant to be this, or maybe like B series boards, then I can't say anything. I did test the B860 gigabyte board though, and it was very impressive, especially for the price. I didn't test the TRFI because, in my opinion, the TRFI option is so irrelevant beyond 65,000. Because realistically, apart from benching, I get it. But for daily, you're not looking at anything higher than 32,000 anyway. So unless you're running some kind of water cooling, then it's fine. Yes, then it's fine. Anyway, I'm actually curious. No, I know that the older B series and Z series and everything, they do 262. I'm not sure about like the recent, let's say very recent new release, new BIOS, everything. I don't know about those because I didn't test. So we have 3 gigahertz on this, perfect. We have a lot of voltage on this. Oh my goodness, that's a lot of voltage. We don't need that much voltage on that. This is same. This is this is still 1.3, which is hilarious. And then the rest I don't see. Okay. Well, let's have a look. Actually, let's do a real test. Let's do a little bit of a like 2 minute test. Let's do a little 2-minute test on this. All right. Yeah, 88 gear 2 primary timings are good in my opinion. These guys are actually ready for 9,000. The rest is very loose except for TRFC and then TREFI, which seem to be they're manually configured by the BIOS itself. Everything else, it's about as loose as it gets. Yeah, it's actually about as loose as it gets. Cool. Good to know. Oh, I get it. Okay, so I can apply 20, or I should say 262K, and then go into Windows and check if it's 262. Yeah. Cool. Cool. Seems like this board is not having a rough time with this, which is expected. 8800 is easy. Even on 4 dimmers, it's somewhat easy, to be honest. So it would be shocking if this board actually just does not do that. But yeah, let's check it out. Let's check it out. Max out TRFI, go into Windows, see what it is. Now keep in mind, this is BIOS F1 is literally the first BIOS that this board comes with. So newer BIOSes might actually change this. I do not possess the power to change that. At least it's responsive, by the way. It's very responsive. Quick post, of course, classic Giga. Without cope volts. Okay. You are correct. They do actually limit it. Oh, that's interesting. Good information. I actually didn't realize that that's a thing. I will have to consult with Gigabyte with this, about this. Yeah. They're gonna get a message. No, I'm actually just thinking 9,000. Is it any easier than it was before? Because before it was just a pain. Is this still Gear 2? I would assume. Right. Is it any easier than before? I should have done voltages, to be honest. I don't want to be pushing this little thing too far. It doesn't need to. My ear is itching. Easy, seems like. So realistically, this CPU should be going to the 9200 mark, and then it kind of starts falling over a little bit. But let's see the votes. Okay, that's fine actually. Still quite a lot. No change, no change. We don't see VDD2, but I assume 1.4. 1.4? Doesn't the profile say 1.45? Okay, I'm a little bit surprised by that. This might actually be ideal. Wait. But I changed it. I put it back to auto. Is this a bug? It's a bug. And this is now maxed out. Not really, actually, no. It's still tighter than stock. But it's much higher than before. What? Okay. What? Intel experience. What is going on? It's a bug, yeah? You think it's an ASRock bug? And I will drain the power. Once I do this, I drain power, and then we go back in. Draining power. There we go. So let's see. I didn't set gear 2. I'm so used to it being just gear 2 automatically. Okay, so let's set gear 2. Ah, yes, the 030507 classic. If I have PTSD from those. Right. Yeah, there we go. We're back. Okay, we're back. Good. Do we have all the votes? Yeah, perfect. Okay. Another short test. With this. Of course, I want to limit this GPU so I don't get 600 watts of hot air in my room. And a little TM5. So far, very easy. more convenient than, for example, the Tachyon at the beginning, right? At the beginning, the Tachyon is, I mean, it still is a little bit above 9,000. It's a bit all over the place. It doesn't really show any kind of a competent stability, reliability. It's only up to 9,000. It's like 8933. You just runs it comfortably, and then you put it to 9,000 and it just falls over. So something internally needs to be changing when you reach the 9,000 and exceed it. And there should be access to that actually, but there is no access to that. And this board does not have access to that because there's no XOC BIOS for it. Looks promising. Cool. Okay, let's just straight up jump to VT3. I know I'm just skipping tests basically. Where do I put you? I put you right here. CPU temp, again, absolutely amazing. I can measure actually the VRM temperature. Well, it does not care. The VRM says it's 51 degrees so far. Even without a heatsink, the VRM doesn't really care about the load. It's going up, of course, right? 53 now, but 53 for like a full load, well, 250 watt full load. It's completely fine. Does not mind the load at all. I can still even touch it. So it's definitely not in the 60s yet. Let's see the score. If the score is gonna be around 1.14, maybe a little bit less, then we're fine. If we're under 1, then we might be glitching out the ME a little bit, which requires a just a power cycle, right? Just pull the power, drain it, power it back on, and we're good to go. And then the score comes back. That's just arrow-like. Sadly, like, I can't see the voltages of the CPU. Like, that's such a shame. So we're slightly less. So that might just be the 3D load messing with it. Or it actually might also be the very loose timings, because the timings are very loose. Now, let's push frequency. I'm curious. Does this do 92? Let's push the frequency. So, well, I'm just gonna raise this. And sayonara. Let's see. Never mind. No way. Oh, it's already over. Oh, no way. I'll wait 3 times. Let's go turtle mode. How good is safe boot on this board? I have a lot of confidence in it, so do not disappoint. Classic. Good. Gigabyte safe mode is RST switch in safe mode or safe boot. So good. You said it right here, Ryan. So this, set this button to boot in safe mode. Best thing they've ever done. It's so good. Love it. Anyway, let me see if potentially the 92 fixes stuff, and I'll reduce one multiplier right here. What kind of timings do we have? Yeah, that's fine. That's also fine. That's also fine. Sometimes. Right, one more shot. Let's see. Is it gonna be 28, 79, 54? 31. Ah, very long 31. Okay, sometimes that happens, and then it retries a couple times, and then it works. Unless the 31 was in fact just long. Usually when 31 is long, it just does this. Yeah, okay. 54. And then let's see. So second time, sometimes it also hangs, and then the third time it successfully goes past. There it goes. Second time it actually goes past. It was only because we came from a safe mode profile to an actual like over 9,000. Over 9,000! And it has to reset. So here we go. We have 9133. Not bad, not bad. So we're kind of approaching the limit of this CPU in the configuration that we're running it in. Now let's see if it actually runs. Again, I know these are stock timings. Yeah, these are stock timings. Nothing special, nothing tight. There's plenty of work possible on the timing side. I'm just trying to push frequency. So let's see. Just TM5 alone. We have quite a bit of issues running TM5. So yeah, this is our limit, it seems like. Beyond this, it is an enormous time investment to actually find out what exactly makes it work. I will try one thing. And if it helps, perfect. If it doesn't help, we're moving on. Okay? They have disappeared. It's a bit of a throw. A bit of a throw. And I'm not sure if this actually applies to both channels or not. Hopefully it does. I don't think there's anything else except for maybe memory voltage, which might actually help. There we go. Yeah. Okay, we'll see. Also, oh, I would have to, right. There's two more options in the training options. Yeah. Training options, and then it's correct. But let's just go in, see how it goes, and if it doesn't work, then we're cooked. Right, let's bust this open, and let's bust this one open. Nope, still explosion. Yeah, it's a bit cooked. So you would need, at this point, you would need to invest time to actually like find out what exactly is making this error out so quickly, and how to like get it to work a little bit better. We would be sitting here for hours and hours and hours trying to figure that out. It's just not worth realistically. case. I will use the 8800 profile and then just do straight tight timings. Tighter timings. I'm gonna use this. Of course, of course, of course, of course. Oh, that's a good one. Technically it's this if I want to go a little bit loose on it. Funnily enough, the board automatically went tighter than this on 8800. These guys I sometimes touch, but realistically not needed here. 26. I'm gonna have to check if that's actually 26. Cute. I'm gonna enable ROM training. I couldn't care less. Where's ROM training? Yeah, so there's that bug where if you press and hold up or down, the two menus change, but the rest of the menu of the BIOS does not change. So it appears like it's not moving, but when you stop, the whole thing appears. So the whole picture appears again. It's a weird bug with this new BIOS. Internal VCCSA, we don't have to touch that. Doesn't need that much voltage, but I'm a fan of it because I don't want to be running into memory instability unnecessarily. So, bank. Now let's test the actual performance of this. How does it perform? Funnily enough, it actually restarts, hard resets. How's the post? Easy. Yeah, it is a board that makes 8800 and 9000 seems like it makes it very easy, but again, when you're exceeding that speed is where it really becomes a bit troublesome. Now, I don't know about the new BIOS though. How much newer is it? February, April. It's 2 months, basically 2 months newer. Interesting. So, yeah, that was very easy to configure if you know what to do. I have one thing in mind I want to test because MSI actually fixed this. So we have 25. I can put this to 22. But MSI fixed this, by the way. WR, you can lower it below 56. You can lower it to about 24 and it will still scale and not lose performance. So I could test that along with these guys. So, IDA, does it not find it? Please tell me it works actually. Please, 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 please. Okay, cool. Oh, it's the trial version. Never mind. Hold on. Is it this? Yeah. Do I even have it? I'm not even sure. Ooh, maybe I have the old. Could I possibly have the old version here? Let me see. Good. Okay, we're back. Good stuff. Let's see it. So we check the speed, the write speed specifically. So back, yeah. Oh, 137. That's pretty respectable, by the way. Not bad for 88. That's pretty respectable. Good stuff. What's the latency? Its latency should be like around 69. Right on the 70 mark, basically. Yeah. Right on the 70 mark. Good, very respectable actually. Good stuff. Nice. Okay, so next up is the 3 timings. So 22, 22, and then 56 down to 24, and see if we lose performance, if Gigabyte finally managed to solve that issue. Now again, this is the first BIOS, so they might have potentially done something in the new BIOS. I don't know what they did on the new BIOS, but here they are. So 24, then 22, 22, send it. And I actually do not have much hope for this, by the way. I feel like it's just gonna tank in write performance. And we're gonna see like 60 gigabytes per second. Because that's what usually happens. And gigabytes somehow haven't managed to figure that one out. It's related to CCD timing. But they haven't figured that one out yet. I was talking about it at the very beginning after testing the OCF, but it just was never done. It was never done with Gigabyte. So, of course, 16, 22, 24, and we expect a write performance to tank massively. See, 36 already, so let's see. Yeah. Okay, still the same issue. It is what it is. It's not that big of a deal. It's not that big of a deal. You just use 56 and you're fine. On WR. It's okay. Okay, so I will actually use this little profile with the 56, and I will move on to more CPU overclocking because I'm actually curious what the profiles do. So 70, it's fine. Let's go straight back and actually try the CPU OC, because MSI right now, in my opinion, has the best overclocking experience for Arrow Lake when it comes to CPU overclocking. It's the simplest, it's the more straightforward, and it works, while others have very limited options that don't really work. So we'll see. Let's see how this overclocking works on this. Just need to get my performance back. We'll save this as 8800. Let's have a look. First up is Intel Default Extreme. Wait, wasn't there... yeah. Extreme mode. Unleash. Okay, so it sets it to unleash. Did it actually just lock my memory, by the way? It locked my memory options. Hello? What? Okay, so it didn't change the voltage. Let's see. If it shuts off, I will shut it off fully. That's how you properly operate with this platform. You need to fully shut it off, do a power cycle, and then turn it back on. And then you get the right results. Usually, well, with the newer ME, most of the boards actually are able to get back the performance and like properly set themselves up after about 30 seconds of shuffling the power, draining, right? In the past, it took 24 hours or longer to get the performance back. It didn't matter. You could remove the battery, you could CMOS it, didn't matter. You just couldn't get the performance back. But they fixed it. They fixed it. I appreciate the buttons, by the way. The buttons on the I/O. Now, they're useless for a normal user, but this is essentially not really aimed at a normal user. These, funnily enough, by the way, I think even other boards that are aimed at normal configurations have these buttons on the backside, which is hilarious. Like Gigabyte is going full on more overclock centric boards with these platforms. So you have boards with postcode at 140, 130 euros, like the B860, for example. I have a couple right here, by the way. Look, I have a couple of them right here. There they are. Look. They've been going hard with the more overclock-centric features on their boards, regardless of the fact that the board is actually just aimed at a normal person, you know? So I respect that. That's pretty nice. All right, let's have a look at the actual CPU. But I think actually these the Unleash profile reduces the performance because the Intel default settings have been optimized so well by Intel that they outperform, straight out outperform the old Unleash and like the extreme profiles from ASRock and Gigabyte and Asus and so on. That's the hilarious part. You just, if you want more power through the CPU and get a little bit more performance in all-core workloads, you just increase the power limit of the CPU and keep the Intel default baseline profile and it will perform the best, which is hilarious. Anyway, we can see that suddenly so 3.4 on NGU, that's hilarious. What happened to my memory? Let's see. 5.6, which is let's see, is it static? Oh, it is actually. All cores are now 5.6, so it's all core turbo. I think it's trying to it's trying to apply its high bandwidth, low latency over my profile, I think. Oh, that is funny. That's so these guys are changed. The rest is same because it applies some of my profile, and it applies some of the high bandwidth, low. I would assume that high bandwidth, low latency is responsible for this because they usually do this. That's hilarious. Let's see the voltages. Voltages are set. Good. Oh, they set VNN. Never mind. VNN A on is 850. That's same. This is same. Okay, so seems like voltages did not change. How reliable is this? What's the power limits? Full maxed out power limit. Well, let's see. Ooh! Oh, it pushed E-cores as well. Oh, that's crazy! Ooh, the Unleash profile definitely is an Unleash profile. Okay. And the input voltage is still completely fine, by the way. However, like the VRM voltage, you can see it right here. The VRM voltage, yeah, the VRM voltage is up there, but the actual on die VCC in voltage is fine. Oh, that is crazy. Gigabyte, dude, what the hell? That's not bad, actually. Like, that's hilariously fast. I have one test. It's right here, actually. I am actually scared. In fact, I could have just ran the, we all know the extreme version of Limpack, you know? I could have just ran the extreme version. That is a lot of power. That is a lot of power. What the? Oh, I'm gonna have to actually wait. I'm gonna have to wait. That is a lot of power. But the VRM doesn't care, by the way. I'm touching the VRM. It doesn't care. Is it gonna be what's the gigaflops? Is it gonna be 1,300? It is 1,300. Let's see the power. 600 watts through the CPU. 600 watts. I love it. It's delidded and everything. I love it, love it, love it, love it. It is definitely it's throttling a little bit towards the end. Let's see the core temperature, by the way. The E cores are hot as fuck, by the way.
That's unleashed.
Dude, the E cores are hotter than the P cores. Like that is hilarious, but yeah, they are. Like straight up. Oh, that's funny. Nah, that is cool. That is cool. Not bad, not bad. I love Limpack. Ah, that is funny. That's why I wanted to test this. So 600 watts through the VRM. I'm literally touching the VRM. It's not 60 degrees. If it was 60 degrees, I would not be able to touch it. So VRM does not give a crap. Oh, that is crazy, bro. Wow. I don't like the fact that they're trying to apply high bandwidth, low latency over my profile as well, which is hilarious, but it is what it is. That's what they do. It's fine. So NGU, realistically, this could be this, and this is 34. That's fine. But I need the VNNA. Oh, VNNA on is not set actually. Oh, that's interesting. I remember setting it, but no, I did not. But yeah. They apply a good VNNA on voltage for this, and I know that this CPU can actually do 40 D2D at 1.1, so I'm gonna actually test this now. This is, let me think. Yeah, they're basically, dude, that is a scary profile for a normal CPU with normal cooling. Very scary. Like that thing is gonna be 105 degrees permanently under load. So, and this is a good CPU as well on top of that, by the way. It's not only delidded and custom cooling on the CPU and everything. It's also a good one. So that means that the VID voltages requested by the CPU are lower than others that would be, let's say, worse, you know? And those would be even hotter then, you know? That is wild. Let me see. So I usually start with 3D Mark Time Spy. If it scores 20... Oh, actually, I didn't test the D2D stability. But if it scores 24 plus, we're good. Let's see. It should. In everything considered, it should score 24 plus. Maybe the memory speed might be holding it back. Actually, the memory might actually be holding it back a little bit with the TREFI. Aha, so 23. Yeah, that's a bit underperforming in my opinion. No wonder. No wonder it's underperforming. Does it override the profile? I'm actually very curious. I want to do the Intel baseline profile. I'll do a BIOS update. I feel like I want to do the BIOS update. Now I'm actually very curious because this was interesting. But I feel like the Intel baseline profile will be colder and will score the same, if not more. Come on. USB, come on. Get out. Okay. Ooh, never mind. That's smart. I will save boot it. Easy. Oh my god, I just got a heart attack. I just got a heart attack, guys. I was logged out of Gmail. I was like, ah, hell no. It logged me out of my Gmail. I was like, hell no, bro. Holy smokes.
Heat attack with 32, I hope right.
I hope, yeah. Me too. Anyway. We need to set load defaults and jump back in, update the BIOS. So far, apart from the fact that the board does not really have the XOC features, I can understand why it doesn't. And the mediocre overclockability of memory compared to what I'm used to on the OCF, for example. Other than that, the board is very capable. It's nice. It's actually good. Yeah. Good features, good stuff on it. Stuff that you would expect. What is it? 5 M.2 slots and so on. It's loaded. So, how do we flash the BIOS again? Like this. So next up, I'm actually going to use the Intel profile, the Intel default profile. We'll see what it is. And then we're just going to go from there, basically. Maybe increase the multiplier of the CPU, see if that works, if it allows the CPU to boost higher than all-core clock enhancement and so on, multi-core enhancement, whatever. Because I've seen this behavior on MSI specifically. You would use the default profile, the new one from Intel, and it would massively outperform their MSI's own extreme profile. Because the extreme profile from MSI is kind of like more legacy.
the way that it was in the past, but Intel massively optimized these CPUs to run at the best possible power, the best possible voltage, temperature, obviously, as a result of that, and get the most out of the CPU as much as possible. And it's very noticeable as well because they've been showing up, right, compared to the release, and then even over a year later, it's been a bit grim in terms of performance. But hold on, I'll BRB real quick.
Cat sitting very comfortably around a campfire with its friends. Kate sitting very comfortably around a campfire with its friends. Kate sitting very comfortably around a campfire with its friends. Kate sitting very comfortably around a campfire with its friends.
Oh, wait, I forgot something. I forgot. Cat sitting very comfortably around the campfire. Alright, let's have a look. Now, this feature allows you to increase. No. No. Why does it reset so many times? Why does it reset? It's actually way less active than I thought today, by the way. It's a Saturday afternoon, and there's nobody here. Literally. Like, what? This was supposed to be a, formative stream about the board that literally nobody tested. It's like, what the hell? Again? It's gonna restart 15 times again. Now it goes through, okay. Okay. another one. All right, let's jump in. And I can finally disable these RGBs. Look, they're freaking holy. They are very bright. Did anything change? Nothing really changed in terms of the layout. Settings are exactly the same. These guys are the same as well. That's interesting. Okay, so let's do a base profile again. Again, a base profile. Mouse speed, fast, but there's no LED option here, which I'm disappointed. Never mind, there is! Main theme. Ooh. There is CPU temp. Never mind, my bad, my bad. There it is. Yeah. Direct sense, motherboard sense. We're gonna use the AVX option. See what I mean? That bug, I hate that bug. This. I'm just gonna disable these guys. We're gonna put it to gear 2 so I don't have to switch it later. I don't think I have to set anything else. Save. Base. Oh, LED. LED power off. Save. Okay, the profiles stayed. Did I even update the BIOS? What? What? The profiles stayed. Okay, interesting. So let me just do the 8800 profile again real quick. Wait, did they add? Whoa. Whoa. They added some profiles. Did they change settings here? No, it's still same. They added profiles. Okay. Wait. I need to test this out. Oh, there's so many profiles now. Jesus.
Monster Freak Cyclops Panos there, how are you?
Send it. That's interesting. Oh, it actually just works. Wait a minute. Wait. Oh, the new BIOS actually just makes it so much more interesting. I didn't know. I actually didn't know that they did profiles. That's 10K. Easy. Yeah, they make it easy, bro. What the fuck? Let me see. Aha, yeah, they're using the turbo timings. Don't get confused by the timings, by the way. These are turbo timings. They're half of their actual value. That's cool. Does this run like TM5? Nah, no, it does not. It does not run TM5. Oh well. VNNA on. Ooh, that's a lot of voltage. What the hell? I have 1.3 still. These guys are same. Yeah, interesting. It's a cool little thing. It's a cool little thing. Still doesn't work, sadly. You would need the XOC BIOS for it. Should I try flashing the Tachyon BIOS on this? Ay, ay, ay. Ah, okay. Can you actually do that? What do you mean? Can you actually do that? What? Flash Tachyon? No, probably not. I mean, you could. With enough effort, you probably could. Norm with the sub. 36. Oh, that's 3 years. Holy... What? Did I miss something? What? Does D2D and NGU settings just they don't work or something? Like what happened? Do I need to like set manual voltages or something? Let's see. Okay, so NGU and D2D should just straight up work like this, right? Realistically, this is fine. This is also fine. And that is literally it. That's how NGU and D2D is overclocked. Let me drain this. My god, that is a tough switch.
Why is high at normine?
Alright, let's do this. Oh, I think it reset because I pressed the freaking shave boot button. I think. We'll see. I'm actually curious. Hi, para. Hello. How are you? I'm okay. I'm live, so I should be okay. Otherwise, I would not be live. Why does NGU and D2D not work? Let's see. Without draining the power. When you good next year? In about 10 months. Something like that or something like that. Did they break NGU and am I missing something? What happened? What happened? They broke NGU and D2D. I can't set it. Does it need extreme? I'll put them to auto. Dude, I love the postcode, dude. It almost looks like a digital display on it, but it's a camera. It looks like it is working now. Hold on. It looks like it did something, yeah? Yeah, let's see. Okay. Now we need to get into Windows and check hardware info if it's actually applied. Because I feel like almost it's not gonna be applied. It is applied. So you need to set Intel Extreme Profile. If you want to overclock NGU and D2, that is the silliest thing I've ever seen. But okay, fine. Fine. No problem. We figured it out. No worries. Yes, I have the monster radiator, yeah. That is hilarious. Anyway, let me test if this is reliable. So, 40 D2D and 34 NGU. This is what this CPU is capable of. But let's see if the board cooperates. Because it's a completely different setup, it's a completely different board. Oh, I actually didn't check the device manager. Yeah, you would want to have these, to be honest, but it's fine. So memory should be completely stable here. We're not throttling. That is a really nice profile in my opinion. It's nice in terms of reliability and performance. So far so good, looks good. Yeah, this CPU is very strong actually. In terms of D2D, the fact that it runs 40 D2D at 1.1 volts, very nice. Most CPUs will not do that. Most CPUs will need about 1.12 volts for 40 D2D, if they can even run for 40 D2D. I would say over half of CPUs actually cannot run 40 D2D. They need way too much voltage and they experience reliability issues with PCI Express interface, M.2 slots and so on. And then obviously the PCH connection, right? The DMI, they call it, right? They can't really run 40. So if you hit that like less than 50% of the ones that do run 40 D2D, most of them, vast majority, will need about 1.12 volts on VNN on to be able to run it. And you can see VNN. Okay, it's reading quite a bit higher. I would assume that this is actually 1.1 on the CPU, because you could assume that this is kind of like a missed readout. If it's not, then it's overshooting and it is what it is. But a lot of the CPUs actually, when it comes to these voltages, VCCSA, so system agent voltage, and NGU voltage, and then you have VNN on voltage for D2D overclocking. They are sweet spot voltages. A lot of them, right? A lot of them are very fine sweet spot voltages where an auto value of any kind of auto value would not hit the sweet spot of every single CPU. In fact, a lot of the CPUs have like very varying sweet spots for these voltages, obviously because of the internal resistances of the die and so on. Anomalies, anomalies that come with CPUs like this, especially CPUs like this, because it is a tile based design. It has a separate core with the E core and P core clusters with ring. Then it has a separate SoC, it has a separate memory controller and so on. And those are connected via D2D, right? On a 3D stack, the way, I think they call it 3D stack. Architecture or whatever, right? That introduces enormous variance between the CPUs to a point where you might just plug in a CPU into this board and try to run stock settings and it will crash at stock settings. And then you plug in a second CPU and it will run seamlessly like nothing ever happened. And that's the nature of this platform. That's just the way that it is. I keep repeating myself saying this, but it's just the way that it is. This platform is like that. And I have like a stack of CPUs here, you know. I'm gonna grab half of them basically. This is half of the stack of the CPU. So they've been all tested, pre-tested, binned, and the OCF, because I personally prefer the OCF to bin CPUs. It's the easiest, the fastest one, and so on. I even have the big box, by the way, look. I have the big box. Yeah. So they all show massive variance in the OCF in terms of the memory overclockability, so the SoC itself, or the IMC itself in this aspect. The overclockability of the SoC, which is NGU, and the overclockability of the, or reliability, I should say, of the D2D, and so on. They all vary in various ways, right? Some don't scale voltage, some don't care about the voltage, some don't have sweet spots, some have very fine sweet spots. Some don't do 8800 on the IMC, they just don't run it. Literally, they don't run it. Some of them run 9000 easily, so you could get anything basically. It's kind of like the Ryzen, where you have three choices basically. You get either a really good core, really good FCLK, or really good SoC. Choose one of the three. I was lucky enough to actually get two of them, which would be the core and the FCLK. Sadly, the IMC, or the SoC in this case, is not good, and it's not good to a point where 6600 doesn't run, which if 6600 would run on that CPU, it would be so cracked out, but sadly it does not. It's right here. It's right here. This is the CPU. And I wrote everything on it basically. The camera it did focus. Look, it's the SP122 with the FCLK 2233. VID is insane. But the IMC is not good. The IMC cannot do 6600. Which is a shame, because if it did 6600, it would be the best CPU ever. I got two of them. You can't get all three. You literally cannot get all three. Either it's a bad core, it's a bad IMC, or it's a bad FCLK. Two better ones. I mean, by the way, here's the actual God bin, by the way. Here's a God bin. Now, it's a SP120. The VID is not that good, but it's named God bin for a reason. This thing almost runs 6800. Also, it seems like this motherboard is actually very much capable of running 4034 with 8800 on the memory. I don't know how to actually squeeze this into a screenshot, because I cover quite a lot with the ASRock timing configurator. But essentially it would be like this. Sadly, you don't see the voltages. You see the TM5, you see my ass. Yeah, that's what you can see. Yeah, so it very much comfortably runs this VT3. Let's have a look at the VT3. I'm gonna hide it behind chat, if that's okay. Actually, VT3 usually is kind of good over here. Yeah, like that. That's perfect. And there you go. That covers the name of it, sadly. And then if I do this, you can only see the frequency but not the timings. It is what it is. Anyway, 270 watts. It might actually... Ooh, VRM is quite... Ooh, actually, VRM is kind of hot. Hold on. Let me see. This is 60 degrees now. Yeah, it is, yeah. As predicted, yeah, it is 60 degrees. Look. Dude, knowing how hot something is based on touching it is so useful. On the heatsink, there is no heatsink. VRM temp, dude, like 60 degrees on the VRM is nothing. You remove it, it's right behind me. Look, that's the VRM. That's the VRM heatsink, by the way. Like this. That's the VRM. Of course I removed it. Like, it doesn't need it. Why you remove it? Because I wanted to look at the VRM. It's self-explanatory, no? I wanted to see what the VRM is like. Water block? Why would I need a water block on a VRM that runs 60 degrees under full load without a heatsink? For 3 seconds. Here we go. 3, 2, 1. Ah! Okay. It is about 65 degrees or so. 66. Yeah. It doesn't need a heatsink. Like, realistically, it doesn't need a heatsink. Also, this score is underwhelming. But realistically, it's fine. It's fine. It's fine. Oh, Linkin Park. Is this gonna hit the power limit? Yeah. So it hits the power limit. It's very efficient though. You can see the P cores are actually 5.2, over 5.2. The E cores, however, are 4. Not great. This score is gonna be 116. Oh, that's disappointing. No. Why not? The VRM does not need a heatsink. There is no fan on it. There is no heatsink on it. And it's 60 degrees. It doesn't care. Why not water block? Would be funny. Would be funny. Would be difficult to assemble and actually run. Yes. And pointless. Above all things. It would be pointless above all things. Power limits enable. Okay. Is 180 of power draw chip? That's what. What? You guys are so weird, man. Why are you in this chat? Why are you watching this stream? Explain yourself. Can I? It closed. Not.
Yes.
It's still downclocks. Should I do all core? Yeah, I should. I should do all core enhanced. MC. What's it called? MCE? Yeah. Yeah. MC. Let's go. I do not like downclocking. Let's remove it. Panacos, we pulled 410 before. Is there even a... There is no option for it. Wait. Oh no. Is it this basically? Yeah. Yeah. That's sad. I was expecting the Intel default profile to perform. It did not. So we're basically stuck with the turbo mode, which is this. I will do a dumb. I'll do a dumb. Dumb. Let's do a dumb. I'm doing a dumb. I'm doing a dumb. The VRM temp, it didn't care. It didn't care. It didn't care. Like, the VRM does not care on this board. Also, do I need to power shuffle it? Dude, I feel like these switches, power on, reset, Q flash, and CMOS, they're just gonna die, basically. Alright, let's see if it... Does it even... What happened, board? Board, what are you doing? What happened, bruv? What happened? Why is there no multi-core enhancement? Dude, that was such a good option if you wanted to do, like... If you wanted to mess around with the turbo ratios and, like, increase the turbo ratio to a specified, like, desired option or whatever. And it would just, like, legitimately just apply that value. Alright, let's see. Let's see if it's 5.7 now. I'm actually curious. Let's see. It is. Ooh. Now I'm actually curious. Is this a 2000? No, it failed. No, 5.7 doesn't work. But the temp is actually pretty insane though. So we need a bit of an offset. Okay, I'm going into CPU overclocking because I'm actually mildly curious what it does. So we need an offset on the P cores. So, okay, we need an offset on the P cores. How the hell do I... Because if I start changing the CPU core voltages, it might actually mess with everything else. So let's try an offset. So we have V-core voltage mode, adaptive single core V-core, special V-core settings, P-core mode sync, yes, manual, mode, no, plus, oh perfect. Maybe I love it. Oh, you can't do plus, really? Okay. Send it. Just wait, just disabling CPM power. I mean, I could do that. Neppe! What the fuck? Is that? I never see you in this chat, by the way. What the hell? It's the nep. Let's have a look. Ah, yeah, it did mess with the volt. It did mess with the input voltage though. For Duo X, about 10 minutes ago, just joined. Yeah, you're about 3 hours late. Which is fine, by the way. You didn't miss a thing. It's fine. That's not bad, to be honest. It did. Oh, I did. Fuck the. Oh, fucking. That's a lot of power, bro. But it did do 5.7 though. Not bad. So, yeah, overclocking would be a little bit weird on this one, but it's more straightforward than I thought, actually. Dude, I wish DLVR worked on this. Yeah, dude. Okay, so they fixed the overclocking of the CPU quite a lot, actually. So like with the turbo ratios, offset, and so on. I still believe that MSI is better at overclocking the CPU than all of the other brands, as far as I'm concerned. Like OCF or ASRock in this case is the worst one. Second one, it's kind of traded between Asus and Gigabyte technically, and MSI is kind of like the top for CPU OC. Let me see the score. I'm curious. I don't want to run Limpack on this because it's gonna be 500 watts. VRM temp, dude, I can touch it. It doesn't care, man. Like, this VRM does not care. That doesn't put it into safe mode? 90C. What do you mean 90C? It's pulling 400 watts. It's not direct die. It's with an IHS cryo sheet. It's cooling 600 watts from the wall, by the way. This is 600 watts roughly. Ooh, that score is not too great though. Shit. This is what I mean. MSI is insanely efficient in score. Which previously, by the way, Gigabyte was very efficient in CPU scores and like Z790 and so on. MSI on Z890 is really good for CPU scores. That's crazy. So wait, you have to do I even have the other? Wait. I don't even think I have. Wait. I don't have. I could just change dynamic core. Yeah. Interesting. I don't think I have a DLBR option. Yeah. I don't. Yeah. Yeah. Sadly. Man. Tachyon has this on the XOC BIOS. I mean, it's fine. Like the CPU overclocking seems fine. You would have to work on it a little bit. Get the right voltages. Now you don't get the readouts in HWinfo, which is so annoying. But if you can predict what kind of voltages are being applied to the core, if you know the core well, if you know what kind of frequencies run at certain voltages and so on, then you might have a bit of an easier time doing the offsets and everything. Because I just prefer doing offsets. If you do an all core, it's just gonna bug out. So you're just doing offsets to the core frequency and offsets to the voltage, and you're overclocking the CPU by doing that basically. And you need the extreme level 3 extreme mode if you want to do NGU and D2D. Yeah, I do not want to use 200S boost profile. Like, no, we're not doing that. That is a waste of time. Other than that, like that, this is a very capable board. Honestly, if it weren't for the restrictions of the BIOS and then also the 9000 frequency kind of like falling off the cliff, you know, in terms of stability and everything, it would feel like a proper XOC board. Now, I'm used to the OCF. I'm spoiled by the OCF. The OCF just clocks memory really well. So, realistically, I shouldn't be complaining. This is kind of like the average, if not slightly above average for the memory frequency capability. So that's fine. The default stuff is actually fine as well, in my opinion. The presets for the memory is also completely fine, in my opinion. In fact, I feel like at these settings, it might just run 9000 completely fine. Basically, like the profile that I'm running at 8800 here is meant to be a 9000 profile. So I wouldn't be shocked if 9000 just runs because it's a capable CPU. The board seems to be pretty capable. So, yeah. I would say like this board is loaded. Yeah. This board is fully loaded. If you want to have some fun and also like very friendly daily configuration and everything, basically features, daily features, 5 M.2 slots, a lot of USBs on the backside. Everything. It's loaded with everything, including the kind of like the bench table type of stuff. It's a 1 DIMM per channel board and everything. Massive heat sinks. The VRM is capable of doing anything basically with any CPU. Yeah, it's a solid board, definitely. Yeah. So here realistically, if I was doing like a real CPU type of thing, I would disable the C states, and I would just set an offset to the DLVR in voltage. Maybe mess with the load line, but probably not really needed. I would mess with the DLVR, so I'd lower it a little bit, get it a little bit closer to the actual core voltages, and then we would be completely good, by the way. At that point, you have a solid OC on the CPU, you have reliability, you have performance, you are taking care of the temperatures as well, because the higher the delta between the DLVR in and the actual core voltages, the higher the delta, the higher the temperature. So, yeah. Yeah, it's very capable, this thing. Without an XOC BIOS, without anything. What is the best? There is no real best Z890. There's trade-offs to every single one. In my opinion, my personal favorite is the OCF. But I'm biased because I've used it so much, I've tested it so much, I've tested every single BIOS on it, every single thing. I even made profiles for it. You can, if you buy an OCF, you have a preset profile that is basically my profile implemented into the board. So I'm a bit biased towards the OCF because it does everything very well. But it's, again, not the best at everything. It's not the best at CPU OC, for example, right? Then you have the Apex, which fixed a lot of stuff over time. Now it's a fairly good platform. It's very cheap as well, by the way. Apex is very cheap. So if you want an overall really good, daily friendly and feature packed motherboard for a decent, like basically everything, would be the Apex, right? Then you have the Tachyon, which is that's a board that gives you an experience. So you will get incredible Gear 4 speeds, and you can play around with single DIMM Gear 4 overclocking records and everything. Like, you can mess with that. You have some of the XOC BIOSes available on the websites and everything, so you can get an XOC BIOS for it, which will allow you to get those records and everything. But it's not really great for daily. Like, I'm sorry, but that's not really a daily board. Then you have MSI. MSI is incredible in CPU overclocking. Like, absolutely, for this platform, MSI CPU overclocking is probably the best by far, right? But when it comes to memory, then you have like weird settings, weird limits for the settings. For example, 1 volt for VNNA on, which is ridiculous in my opinion. So like stuff like that. MSI for overclocking, it's not friendly, man. Like, I wish it was, by the way. I wish it was great at the limits that you can apply to the voltages and the frequency to the DDR5, for example. But it's just not. It's just really great at CPU and really great at CPU scores as well. Like, scores are topping all of it, basically, all the charts, right? And that's basically it. That's the stack. That's the stack. So overall best, I would say Apex. Best CPU overclocking would be MSI Unify X, or just MSI in general. Best memory overclocking overall, Gear 2, Gear 4, everything, would be the OCF. Gear 4 overclocking for DDR5, Tachyon. That's it. That's it. So no overall best. Yeah, Apex is everything but mem, yeah. Which is hilarious, by the way. Apex is everything but mem. What is the best cheap or this? Just buy this. B860 Elite Wi-Fi Ice. Just buy this. Buy this and be happy. It's so cheap. It's so good. It does everything. It has everything. Just get this. And like I said, this thing just does 9,000. It just does 9,000. Ah, that's good. Similar or better? Well, it's better in efficiency. It's better in all core workloads most of the time, right? It has much better E cores, much better P cores, more efficient obviously, so it's gonna run at lower temperatures and everything compared to a 14900K. Unless obviously if you're power limited, then if it's gonna hit 250 watts, they're probably gonna be running about the same temperature, right? You have a obviously much newer platform, right? Newer features, better support for it as well and everything, right? The one thing that the 4900K excels at is most of the time a tuned 4900K with the memory and everything will perform better in games, obviously, which to nobody's surprise, right? It's better in gaming. But if you do a proper setup, 270K versus a 14900K, 270K honestly is starting to outperform the 14900K because of the hyperthreading. They removed the hyperthreading. They introduced optimizations to the management engine and the BIOS and the scheduling. Windows now has optimized scheduling for it as well. You have drivers that optimize the scheduling for specific tasks and so on. So the Ultra series is really gaining ground in terms of the gaming side, where it was really bad at the beginning and for a very long time. Actually, like, it was very bad for over a year. Now it's actually gaining ground with all of the optimizations and everything. Like, they're really doing some proper work to get it to perform, right? And it's not just promises, empty promises or something like that. No, they're actually doing work to gain ground. So yeah, I would say the Ultra series, with all of its nonsense that's going on with the BIOS situations and the default settings in the BIOS, it is maturing. It is maturing. It's very it's like the price point, for example. The price point is unbeatable, literally unbeatable price point. So that's honestly, like, the price point, in my opinion, is what's really appealing, or making this platform really appealing, right? A board for 130, 140 with postcode, all the features, big VRM, a massive back IO, loads of M.2 slots for 130, 140. Are you serious? And then a CPU, you can put a 24 core CPU for 300 inside of it. So, like, of course, like, I would absolutely go for that over a 8 core 9800 XTD that needs a board that is like €200 or more to get the same feature set. Like, it's a no-brainer, right? Personally, like that's my opinion, because I don't really look for the highest possible FPS and everything. I just look for reliability. I look for all core performance, because I'm doing all core workloads more often than just gaming. And when I'm doing gaming, I don't care about the highest possible FPS. Like, who the hell cares about the highest possible FPS? I'm just trying to game to have a little bit of fun. While I'm watching a stream.
Frame chasing pointless, really.
Yeah. So while I'm watching a stream, while I'm listening to music, while I'm in Discord call, while I'm doing all of these multi-core workloads in the background while gaming, I just want a smooth gaming experience. I just want the FPS to be as smooth as possible, no lag, no stutter, and see that the CPU is not absolutely shitting the bed when doing like multi-core workloads, you know? So that's the answer. That's why I daily at 13900 KS. It's very straightforward. And also, like, this is very solid. Not bad. Like, actually not bad. I'm gonna make a screenshot of this. Do I have a USB inside? Also, like I said, I'm in a yapping mood today. An absolute yap session. Oh no. Please don't hover right now. Please, please, no. Please. Do I have like a name for it already? Actually, I'm gonna name it DDR. Did it potentially overclock the ring as well? Oh, you gotta be kidding me. I will override that screenshot. So, you gotta be kidding me, by the way. Yeah, it's still a buggy platform when it comes to overclocking. Yeah. Okay, so it's still a buggy platform when it comes to this overclocking thing. Let me see if hard reset actually helps it a bit. But if you're just looking for a highest FPS possible, just gaming PC, you're not doing anything else, you know, like not even Discord in the background. Just literally sit behind the PC, launch a game. The XRD is gonna deliver the best possible performance, of course. Like there's no argument against that. It was made for gaming. And that's literally, like, funnily enough, when you think about AMD, do you really think of the normal CPUs? Literally almost nobody thinks about the normal CPUs unless they are a budget-friendly variant or a workflow CPU. So a budget-friendly variant would be the 6 cores, you know, the like 140, 150 euro CPUs, you know. Let's say 7600X and 9600X and so on. They're not even that cheap, by the way, for considering it's just a 6 core. Those are the ones that are talked about. And then like the workflow CPUs were kind of like the 16 core 9950X, for example. Those are like the only CPUs talked about. Everything in between is literally just the XRD. That's it. Nobody is talking about the non-XRD CPUs, bro. Like, that's hilarious. That's all that AMD is known for the freaking XRD. And again, it doesn't apply. Like, I don't know what is the bug with the D2D and NGU, but that is annoying. What do I do here? Max performance profile. Do I just do this? Actually, I have an idea. Hold up. Oh, C states, right? C states. Disable. Wait. So that's vCore single DLVR in. Dynamic. Yeah, I was thinking about that, MapsCorp. I was thinking about that one. It didn't seem like it said anything. Man, yeah. What the my goodness. Okay, let's see. I still don't like that this is why do I need to change the multipliers just so it changes? This is really good, by the way. This is actually really good. Okay, let me see Linkin Park. This might not be stable, by the way. No, we're good. This is good. This is actually good. Yeah, so this is the way. This is the way for CPU OC. So basically you disable C states, you apply some turbo ratios, offsets, you know, That's how you get the ratios to work. And then you just set an offset voltage for the DLVR VN. So you don't absolutely slam the onboard DLVR. There we go. Lead, man. The score is lead. 410 watts. Yeah. What is the power? It's lower than before, by the way. It's lower than before. So you know what the... See, here's the trick. Remember what I said earlier. The bigger the delta between the DLVR in and the actual core voltage, the more heat is going to be produced, right? Because the drop from the DLVR in to the actual core voltage is higher, right? So there's more energy loss inside of that. So that's basically like the DLVR generating heat to lower the voltage. The closer it is, the less heat is produced inside of the CPU. So the CPU right here is colder while pulling the same amount of power, technically the same amount of power. We're reading the core power, not the actual CPU power, right? The CPU overall power is actually lower than before, and the wall power right now is showing 570 watts compared to 600 before. So we basically saved 30 watts by getting the DLVR in voltage closer to the actual core voltage. Good luck understanding that. Okay. Type 1 if you understood what I said. Type 2 if you didn't. What do you mean? 3? 2. Why doesn't it set the D to D and NGU, man? What?
2?
2. Dude, I just want to have D to D and NGU. Are we serious? Is hardware info bugged? Dude, I just wished this. Dude, there is no Arrow Lake platform that would be flawless. There is none. It doesn't exist, man. Either it's really bad memory overclock or really bad voltages, default settings, not working CPU overclocking. D to D and NGU apparently don't work. I will set the extreme again. No. No. Let me set auto. I mean, it's already auto, so it will not do anything. Yeah. It just completely disregards the manual setting. Man. Okay, Gigabyte, you have one issue. One. You need to fix this. That's it. That is my only complaint that needs fixing. There was one more, by the way. Wait, what was it? Ah, right. This thing. This. We need to fix this, bro. We need to fix this. That is not good. That is not good. We need to fix that. But in terms of BIOS, you need to fix this. Like, that is unbelievable. This needs to work. I would assume actually it doesn't work because I said this, right? It doesn't work because of this. What? That's my last shot, by the way. If this doesn't work, then I just bail out. If it doesn't work, then yeah. Okay. It doesn't seem like it works. Okay. Well, that's basically it. I've already said what I think about this board. The one thing that's missing is availability. If I try to search for this board, let's try to search for this board, right? So Z890 Elite Duo X. I can see the listing for it, but there is no availability. Literally, it doesn't exist. So we need to see this board being available. And then I can formulate a rough conclusion for this board, whether or not it's worth or not, because I don't necessarily know the price. I don't know the price for it, what the retail price is. Apparently it's around the 300 mark. And if it's around 300, then you're encroaching into like the higher or mid higher range of the boards, which I wouldn't say that this is not a mid to high range motherboard. It definitely is, actually. The really great VRM, great features, great expandability, great overclocking, and so on. So it is really up there in the mid to high, but it is like 300 plus is expensive. 280 would be fine. 260 to 280 for this board is just exactly where I would personally like to see it. Kind of like 269 would be the right price if I was looking for this board. That would be the right price. Yeah. But if it's anything higher than that, then you're knocking it down, you know? You're knocking it down because of the price point. It's a good board. You just gotta fix a few BIOS bugs. Yeah, this is the main one. Now, again, like I could be doing something wrong with the BIOS, and I might be doing too much with the BIOS and everything to make this not work, because we saw that this worked before, right? With the just normal profile, you know? But we couldn't get the CPU OC dialed in with those settings, you know? So either you prioritize the CPU or you do like prioritize the NGU D2D. You just can't have both at the same time, sadly. Right? So other than that, it's really solid. Like this thing. This thing is really solid. Not bad. Good conclusion. 3.5 hours in. Not bad. Great experience. We did basically most of it, you know? We didn't do H16A and so on, but realistically we would be spending 7 hours if we were doing that. So yeah, realistically, yeah, final closing thoughts on this board. It is completely loaded with features, more than you would have ever asked for. Great overclockability, but it needs a bunch of BIOS fixes, BIOS bug fixes. But other than that, it's out of the box. It is a very solid experience. Yeah. That's it. That's my closing thoughts on it. Finally, because I got this board quite a few days ago, actually. And I finally sat down. It was the right moment to actually do it. So, that's nice. Guys, thank you for joining. Thank you for sticking around with this little kind of like a review type of thing. And I'll see you around. I'm not sure what or when. But keep your eyes peeled. It might be interesting. Have a great weekend. Ciao, ciao, guys.